Okay, we got to method overriding. In this lecture, I'm going to talk about what is method overriding and introduce you to two powerful keywords in C# called virtual and override. Method overriding is simply modifying the implementation of an inherited method. What does it mean? When we use inheritance, there are times that we may want to modify the implementation of a method that we inherited from a base class. Maybe that implementation doesn't apply to a derived class. That's where we can use method overriding. So we override the implementation of an inherited method. Sometimes developers new to C# get confused between method overriding versus method overloading. Overloading is having a method with the same name but different signatures. Overriding, on the other side, is about changing the implementation of an inherited method. Let's take a look at an example. So throughout this course, you have learned about the shape class. So it's the base class for our imaginary PowerPoint application. A shape class can have properties like width, height, position, and so on. And it can also have some methods. To keep things simple, I've only added the draw method here. Now, when we derive a class like circle or image from the shape, the algorithm we use for drawing a circle or an image is different. So that's where we need to change that implementation of the draw method that we inherited from the parent shape class. Doing this in C# is very simple. And that's where we use the virtual and override keywords. So we can change this example to something like this. So all we do here is we decorate the draw method in the base class with a virtual keyword, and that gives us the ability to change that implementation in a derived class. And to do that, we use the override keyword in the derived class. Note that you don't necessarily have to override or change that implementation, but if you want, you can do so by applying the override to that draw method in the derived class. If you don't override that method, the default implementation defined in the base class will be inherited. Now, this technique is extremely powerful, and that's one way to implement polymorphic behavior in C#. Now, I want to keep theory in this lecture to minimum and focus on practicality. So let's start coding and see polymorphism and method overriding in action. Okay, the example I'm going to show you in this lecture, I believe, is an eye-opener. So let's take a look at this piece of code I have written, which is an example of a poorly written piece of code. Then I will show you how to change this code and make it much better. So let's take a look at the classes we have in this project. We have a class called shape, which has a few properties like width, height, a position, which is simply an X and Y, and an enumeration called shape type, which determines the type of that shape. Let's take a look at the shape type enumeration. So shape type is an enumeration, and currently we have support for circles and rectangles. We also have a class called canvas. Here's our canvas class. So this class simply has a method called drawShapes, which receives a list of shapes. Inside this method, we iterate over the list of shapes, and then we do a switch on the type of the shape. So if the shape type is circle, here we have an algorithm that draws a circle. Or if the shape is rectangle, here we're going to have the algorithm for drawing a rectangle. Now this code has a problem. And even though it's a classic example that I'm using for teaching, I've seen the exact same pattern in many real-world applications. So let's see what's the problem with this code. The problem is that next time we decide to add support for a different type of shape, let's say a triangle, we have to go here to shape type enumeration, add a new member here, triangle, and then we have to go modify the canvas class. Here we're going to have another case statement like case shape type dot triangle, and of course here we're going to have some algorithm for drawing a triangle. The problem is every time we define a new shape type, this method is going to be changed, and as a result, the class that contains this method has to be recompiled and redeployed, which means any class in the application that is dependent on this class also needs to be recompiled and redeployed. Same for the shape type. Every time we modify this enumeration and add a new member, any classes that is referencing this, again, is going to be recompiled. So there is a lot of tight coupling here. And there's also another problem. take a look at the canvas class. Imagine if you're going to have support for 10 different types of shapes. This method is going to get really, really fat. Well, you may argue that we can refactor some of this logic here into separate methods, but still the parent method here, draw shapes, is going to be fat and complex. Now, the reason we have this problem with this code is because the shape class itself has only properties. It doesn't have any behavior. It doesn't have any methods. Back to the encapsulation principle of object-oriented programming, we want to encapsulate data and behavior or methods in the same unit. That's a class. Applications designed or developed this way, like the one you see here, have data somewhere, whereas behavior is somewhere else. In this example, data is here, but behavior is inside this canvas method. So we need to encapsulate them into one unit. So let's see what's a better way to write an application like this. So the first thing is I'm going to create a new class called circle. Currently, we don't have inheritance here. We just have a shape class that has a type. So let's create a circle. And we derive it from shape. And another class. Rectangle is also a shape. Now I'm going to get rid of this enumeration here because I want the concept of type of shape be determined in a derived class. So circle is a type of shape. Rectangle is a type of shape. We don't need the shape type enumeration anymore. So let's remove this. And obviously I remove it from the solution here as well. Now back to our canvas class. Obviously this code is broken because the enumeration doesn't exist anymore. And that doesn't matter at all. Because as we explained, here is the behavior around the concept of a circle. So we need to encapsulate that behavior and the data related to that behavior in one unit. So we go back to our circle class here. First, we need to add a method here called draw. So the draw method defines the concept of drawing a shape. Now this method will be inherited by these derived classes. But how we draw a circle is different from a rectangle. The algorithm is different. And that's where we use method overriding. So we declare this method as virtual, so we get a chance to change its implementation in a derived class. So here I go to the circle class. We simply type override, and note that Visual Studio automatically lists all the methods that you can override. So here is the draw method. And here are three methods that we have inherited from the base object class: equals, get hashcode, and toString. I will show you an example of overriding one of these methods later. So let's just get back to our draw method here. Now by default, Visual Studio automatically adds this base.draw method call here. What does it mean? Base is a reference to the parent class. So here we can write any code specific to the circle class itself. And then before or after, if we need to, we can pass the execution to the draw method defined in the parent class. In this example, we don't really need this because the draw method we have in the parent shape class has no implementation. It's just an empty method. So remove this. And here I will have the algorithm for drawing a circle. Let's get back to our canvas class. Note that here is the algorithm for drawing a circle, which was not encapsulated with the data about circle in one unit. The behavior was different somewhere else in the application. And that's a symptom of poorly designed application. So I just cut this from here and put it back here. We do a similar technique with the rectangle class. So override, tab, and enter. We don't need this line. Now let's get back to the canvas and grab this line, which is for drawing a rectangle, and paste it here. Now let's go back to the canvas again. So we don't need the circle and rectangle anymore. And let's say currently our application does not have support for triangle. Then I will show you how we can add support for triangle without breaking existing code. without the need to recompile and redeploy many classes. So let's get rid of all this switch block here. Now inside the for each block, what we do is we simply call the draw method of the shape. And here's where the magic happens. Let's take a look here. So the parameter for this method is of type list of shapes. So every element of this list is going to be a shape object or an object whose type derives from the shape class. And that's what you learned earlier. So at runtime, what happens here is we iterate over this list of shapes, but we may have a circle in the first element of this list, or the second element might be a rectangle. So when we call this draw method here, even though we're talking about shapes, at runtime, that shape object might be a circle or a rectangle. So when we call the draw method, the draw in the circle will be called, or the draw in the rectangle will be called. And this is what we call polymorphism. So poly in Greek means many. Morph means form. Polymorphism means many forms. So you see we have the concept of shape and the concept of drawing a shape, but that concept can have different forms depending on the objects we have at runtime. Let's get back to the canvas class again. Look, the implementation here is very simple. Okay, now let's go to the program class. Okay, here in the main method, first we create a list of shapes. Then we create a canvas and we pass the list of shapes to the draw shapes method of the canvas. Previously, I used the type enumeration. And that's why, because I deleted the type enumeration, this code is now broken. Basically, what we need to do here is to store different types of shapes in this list. So I want the first object to be a circle. So let's add a new circle here. And let's not worry about setting the properties. And here, let's put a rectangle. Now to show you exactly what happens at runtime, I put a breakpoint here with F9. Run the application in the debug mode with F5. Now we can step into this method with F11. Okay, now let's put a watch on the shapes object passed to this method. So in the watch window, type shapes. So that's a list with two objects. Let's expand this list. Note that the first object is a circle and the second one is a rectangle. Again, because it's a list of shapes, an element in the list can be a shape object or an object whose type derives from the shape. Okay, let's collapse this. Now we continue execution with F10. One more. Now we are inside the for each block. Let's put a watch on the shape object. So here is the current shape. And as you see, it's a circle. Let's continue execution with F10. Now we step into this method with F11. Note that now we are inside the draw method of a circle. So let's continue execution with F10. One more. Now this iteration is over. Let's continue execution. Here's the second iteration. And note that in the watch window, now our shape object is referencing a rectangle. So if we continue execution here, now we step into this draw method. That takes us to the draw method of the rectangle. Okay, now let's stop the debugger with Shift and F5. So back to our canvas class. Again, I want to re-emphasize this one more time. So even though here we are dealing with a list of shapes, at runtime, the objects we have in the list can be a shape or any object whose type derives from the shape. Now, because we declared the draw method in the shape class as virtual, that gives us the ability to override it in derived classes, which means at runtime, if this shape is a circle, the draw method of the circle will be called. Or if it's a rectangle, the draw method of the rectangle will be called. Now, what's the benefit of this approach? There are a number of benefits. The first one is, if you remember previously, we had various algorithms in this draw shapes method. We had algorithm for drawing a rectangle, we had algorithm for drawing a circle, and imagine as we add support for more shapes, this method is going to get fatter and fatter. We fixed this problem by using encapsulation such that we encapsulate the concept of drawing a circle as well as the attributes or properties about the circle in one unit. So here, if you want to have some extra properties about the circle, we can define them here. All these members in the circle class are highly related. So pieces of the code that are related are in one unit as opposed to all over the place. So this way, the circle class doesn't get bulky because it only knows about the concept of circle. Similarly, the canvas class doesn't get bulky either. The implementation is very simple. Now, tomorrow, if we decide to add support for a different type of shape, let's say triangle, this method is not going to change. Let's see what happens. So we go back here to our shape file, and let's create a new class. Call it triangle and derive it from shape. And now override the draw method. And here we implement the algorithm for drawing a triangle. So console.writeLine, draw a triangle. Now the interesting thing here is we simply added a new class called triangle, but this had absolutely no impact on the shape class because shape class knows nothing about triangle. It also had absolutely no effect on the rectangle. Rectangle is not changed, it's not affected. Same for circle. And same for canvas. Our canvas class only knows about the shapes. Whatever shape they are at runtime, who knows, who cares? The canvas doesn't have to worry about it. So this way, with polymorphism, we can create new shapes by simply creating new classes, and that has absolutely zero impact in our existing classes. And this is a sign of loosely coupled applications. Well, that's pretty much it for this lecture. I hope you enjoyed it, and thank you for watching.